Hey class, in this video, we're going to be discussing solving radical equations. Okay. And I want to give it just a little bit of a primer on what a radical equation is and how it's related to radical expressions, something that we already touched on in module 2. Okay. So a radical expression is something that we also call a root. And we've seen them that we use this symbol n root x to indicate the nth root of x, where this number n is referred to as the index of the root. And that index n can be any number. We saw that with the square root, it has an index of 2. We also encountered the cube root, which has an index of 3. But there are as many indices as there are numbers that you could name. Okay. In some of those problems that we saw in previous sections, we wanted to think of this expression as asking what number raised to the nth power results in x, which we called the radicand. Okay. What number raised to some n power gives us that number on the inside? And so another way to reformulate it is by setting up this equation where something is being raised to that power n equals that radicand. Okay, so usually we're solving for x, but in this example, the x is going to be a known value. It's going to be given by the problem. And what we're trying to solve for is figure out what is this number inside the parentheses here, at least written as this expression with an exponent. Okay. And we saw that when we were solving quadratic equations, that we could, observe this relationship between the square root and the squaring exponent, the second power, that those operations, square roots and squaring, cancel each other out. Now, that's because roots are related to exponents in that if they share the common index, whatever that number n is, that they are inverses of each other, and so those operations will cancel out with each other. We use this property or this idea to simplify radical expressions, but also to solve some quadratic equations using the square root property. Okay, so let's take a look at one example just so that we can kind of refresh ourselves on how roots and exponents are related to each other. This problem is asking us to find the fourth root of 112. And so one way that I taught you guys how to go about simplifying this radical expression is by first interrogating the radicand. So we grab that radicand over here and then do some scratch work on the side. So we have 112. And we want to go ahead and break that down with a prime factor tree. Okay, so with that prime factor tree, we want to go ahead and think of all or any, rather, any two numbers that will multiply to make 112. Okay, so if nothing is coming to your head immediately, I know that 112 is like a non-standard number that we work with in our times tables. So what you might do is just grab your calculator and go with 112. I know it's an even number. Let's just divide that by half. So divide it in two. And we know what that's going to be 2 times 56. And now 56 might be a little bit more manageable or easier to work with. If it's not, if those factors for 56 aren't coming to you immediately, we can just take 56, divide that by 2. We get 2 times 28. And now this is going to be 2 times 14. 2 times 7, and then 7's prime, and we're done with our prime factor tree. Okay, so here we want to be very careful because the index is kind of a clue as to how we want to go about simplifying this expression. The index here is 4. So what we should remind ourselves is that the fourth root cancels or is the inverse of the fourth power. So even though I could write this as 2 squared times 7, I'm going to write this as a fourth power because I'm trying to use that index 4 to cancel out as many fourth powers as possible. So instead, I'm going to take these 4 copies of 2 and call that 2 to the 4th power times this singleton 7 that we have there all by itself. So now I have this expression 2 to the 4th power times 7. Okay. It's a little bit different from how we were simplifying square roots, but remind yourself, this is not a square root. We're taking a 4th root. But pretty much the mechanics are the same here. I'm going to go ahead and split up the radical by taking the 4th root of these guys individually. And anywhere I have the index of my root matching my exponent, I can cancel those out. So the 4th root of 112 can be rewritten as 2 times the 4th root of 7, which stays inside the radical expression because it doesn't have that exponent of 4, which will allow me to sort of unlock it or cancel it out and bring the 7 out to be with the 2. Okay. So since that is all of the 4th powers that I could cancel out, this is going to have to be my final answer. This is simplified as much as possible. Okay. And then as we did with the previous radical expressions, we can go back to the calculator. And if we really badly wanted to check this to make sure that we got the correct answer, you can, in your calculator, if you have a TI-84, to get the 4th root of 112, we're going to type a 4 and then hit the math button and scroll down to this 5th option, which has this little X root symbol. Hit enter. Now we have a 4th root of 112, and that's equal to this strange decimal representation of the number 3.2531, blah, blah, blah. Okay. We don't really care about the decimal representation, but we're going to use it to check, is this answer correct? And if we type in 2 and then times the 4th root, so I'm going to type a 4, go to math, go down to the 5th option, and now we can do 2 times the 4th root of 7. If we get the same thing, as far as our decimal representation is concerned, then we did that problem correctly and we correctly simplified that radical. Okay. So that shouldn't be too far-fetched for you guys. If you need some help with simplifying radicals, I advise you guys to go back and watch that video on simplifying radicals, the first one that we did, because really we're using this kind of as a launch pad to talk about solving radical equations. Okay. And these radical equations are equations that are going to involve things like square roots or 3rd roots or 4th roots even. Okay. And we need to think about how can we logically step through these equations so that we can solve and get that missing variable x or y or whatever the variable happens to be labeled as. Okay. So let's approach this very gingerly, very carefully. First, what we want to do is maybe write some basic steps here. So over on the side, I'm going to put some scratch work. My first step is always going to be to make sure that we isolate the radical expression. And so in this problem, the radical expression is the square root of 2x minus 1. Now, you might have a little bit of anxiety or a little bit of reluctance to call that the radical expression because there's a lot of terms inside that square root. Okay, but that's okay. They're all trapped inside the square root symbolically. And so you can think of that as one big chunk of information. But that's the root, that's the radical expression, and it's all by itself over here on the left side of my equation. So this is done. Okay. The next thing we want to do is we want to use the correct exponent or the correct power to cancel out the radical. Okay. And since this is a square root, what I'm going to do is rewrite this as 2x minus 1, just rewriting the exact same equation. But if I recognize that this is a square root, then you have to recognize that the opposite of that is the square operation, or sometimes we just call it the power 2. Okay. So similar to the square root property here, where we would usually say, oh, if there's a square on one side of the equations, if we've isolated the squared term, we'll take the square root of both sides. In this case, we've isolated the square root. And so what we're going to do instead is isolate that and then cancel it out using the second power. Okay. So what I mean by that is that we're now going to get to introduce this second power here. Take the second power of both sides. So apply the second power to both sides of my equation. And as you guys know, the second power and the square root cancel each other out. So what I should be left with is 2x minus 1 is equal to, and over here we have 3 to the second power, which if you need to remind yourself, that's going to be 3 times 3, which simplifies to 9. Okay. So now that we've done that, we've canceled out the root. We no longer have exponents because we simplified all the exponents that we could. And what we're left with is just a linear equation. Okay. Linear equation because we have an x in there, but we don't have any exponents on it. So if we can solve this linear equation, then that'll be the end of this problem, right? So we use the correct exponent to cancel out the radical. We simplify it a little bit, so maybe that'll be my third step. Simplify any expressions that we might have. And then here, we're going to solve the equation. Okay. So now that we have this linear equation, it should be back to test 1 material or module 1 material. So you should be able to recognize that, oh, to get this x by itself, we first need to add 1 to both sides, cancel out that 1. We'll get a 2x is equal to, now this is going to be 10. We'll divide both sides by 2 so that we cancel out those 2's. And now we have x is equal to 5. Okay. And that's going to be our solution. But we want to take one extra precaution when we're solving radical equations, and that is this. 5th step, and this is probably the most important step, is we want to check our solutions. Okay. In this problem, we only have one solution, one potential solution. And the way you check it is by simply taking that solution and plugging it back into the original problem. So to check this, we would write the square root of 2 times 5 minus 1 is equal to 3. Okay. And then we don't know if this is true. What we need to do is just simplify this. And we could do this in the calculator if we wanted to. You could throw this whole thing in the calculator exactly the way we wrote it down. Square root of 2 times 5 minus 1. Simplify that part. So I have 3 is equal to 3, which is a true statement. And so that tells me that this is, in fact, the correct answer to this problem. So I can write my solution set as 5. And there's my solution set. Okay. So we're going to take a look at 4 more similar problems. But before we get into that, I really just have to say that there's not going to be a one-size-fits-all manual or set of steps to solve these radical equations. You are piecing together a strategy based on what you know about how we can cancel out the radical with the appropriate exponent. And then once you do that and you cancel out the radical appropriately, you should end up with either a linear equation or a quadratic equation, which we should know how to solve at this point. Okay. Once you solve those equations, you may have one solution, 2 solutions, but those are only going to be potential solutions. We need to check them by plugging him back into the original problem to see if we get a true statement. If we do, then great, we can put that in our solution set and call it a day. But it's possible that you might get what are called extraneous solutions. You could think of them as false solutions or trap doors, that if I plug one of my solutions back into the original equation and I don't get a true statement, well, I have to throw that solution away. Okay. So like I said, we may get one or two potential solutions, but once we go through the process of checking those solutions, we'll see that we could have two solutions, but we might throw one away and only end up with one solution. And then in a really unfortunate series of events, it's possible that you might have to throw away both solutions and then say that your solution set is empty. In other words, there is no solution. Okay, so let's get into it in a moment and do some more practice problems. Okay, in this problem, we see that we're dealing with the cube root of 4x plus 7 minus 2 equals 0. And we want to approach this one just as carefully as we did the last. What we're going to do here is go ahead and list some of our steps. So the first step that we want to take is always to isolate the radical expression. Okay, so in this problem, the radical expression that we're talking about is the cube root of 4x plus 7. We want to get this all by itself. So in order to do that, we have to add this 2 over to the other side of the equation. So now we'll have the cube root of 4x plus 7 is equal to 2. The next step is going to be to use the correct power or exponent to cancel the radical expression or the root, okay? Notice that we have an index of 3 for this radical expression, okay? So that tells me that I need to use, to cancel out the cube root, I'm going to have to use the third power, okay? So let me go ahead and rewrite this problem. We have the cube root of 4x plus 7 equals 2. Next, we will wrap this expression in parentheses and raise it to the third power. Do the same on the right-hand side of this equation. And now the third root and the third power will cancel each other out. So we have 4x plus 7 is equal to 2 to the third power. Again, if you have to remind yourself what we're actually doing here, it's 2 times 2 times 2. So that's going to be 8. You can also put that in the calculator, so you don't have to do this by hand, okay? It looks like we're dealing with a linear equation. So the next step we're going to take is to solve the linear equation. And remember, when we're solving a linear equation, we're just trying to get x is equal to blank. Okay, so we want to get the x by itself. So here we'll subtract 7 from both sides. Okay. Then we'll have 4x is equal to 1. And finally, we can divide by 4 on both sides so that we now have x is equal to 1/4. Okay. Remember, this is just my potential solution. So our last step is always going to be to check the solution. And the way we'll do that is take the original problem, the cube root of 4x, but this time we're going to put 1/4 into our equation plus 7 minus 2 equals 0. And we need to check to see if this is a true statement. Okay. So what you can do if you're not fond of evaluating that stuff with the fractions and the root is you can put this whole thing into the calculator, and we'll just we'll press the button 3, go to math, go down to this fifth option to get the cube root. 4 times, we'll go ahead and put our fancy fraction in there, 1 over 4 plus 7. And then if you want, you can subtract the 2 also. Minus 2, just make sure it's not underneath the radical. And we get 0 is equal to 0, which is a true statement. So that tells us that this is a correct solution, and it's the only one we have. So our solution set is just going to contain 1 over 4. Okay. Let's take a look at another one of these equations. Okay, let's take a look at another one of these problems. Okay, in this one we have the square root. Let me go ahead and make this a little bit, there we go. The square root of 3x plus 1 equals 4. Okay, so as always, I'll put my scratch work over here and just kind of some notes on how we should approach this problem. So first, we need to make sure that the radical expression is isolated. So isolate the radical. And sure enough, that radical expression is already isolated. So there's nothing more we have to do there with the radical expression. So I'm just going to rewrite the problem, 3x plus 1 equals 4. The next step is going to be to cancel the radical with the correct exponent. Okay. So if we have a square root, what is the opposite of the square root, or what is the exponent that has the same index? And that's going to be the square operation. So remember, this is square root. Don't confuse that with the square. Okay. So we're going to use the square here to take the square of both sides of our equation. Because we know that the square root and the second power will cancel each other out, what we'll be left with is 3x plus 1 over here on the left side of the equation. And then 4 squared is going to be 4 times 4, which is 16. Okay. All right. Once we do that, we can go ahead and simplify our equation, or solve our equation, right? So we can solve, and here we have another linear equation. Okay, so I'm just going to subtract the 1 here. That cancels out. I now have 3x is equal to 15. And then the last step will be simply to divide by 3 on both sides. So now I have x is equal to 5. And our final step is always going to be to check the solution by plugging it back into the original problem. So our original problem was the square root of 3 times x, which is 5, or at least we think it's 5 right now, plus 1 equals 4. And we're asking, is this a true statement? So if I evaluate this in the calculator, do I get 4? I'll go over here and take the square root of 3 times 5 plus 1. And I'm getting 4 is equal to 4, which is a true statement. So that tells me that this is the correct answer, correct solution to my problem. So my solution set is just 5. Okay, weird looking 5, but just a 5. Okay. All right, let's do another one. Because as we see that some of these equations end up with just linear equations, but others will be a little bit more complicated. So we're going to go through the same steps here. So if you need a pause, just to give yourself a little bit of a break, I highly recommend taking as many breaks as you can afford. The first step is always to isolate the radical. So is this radical expression by itself? Well, sure enough, it is. So we'll just take the square root of x minus 3 equal to x minus 5. And now we'll just move on to step number 2, which is use the correct exponent to cancel the radical. And so take a moment and ask yourself, what's the radical here? What is its index? And then what exponent is going to cancel that out? So if we're dealing with the square root, then its inverse is going to be the second power, okay? So what we'll do is apply the second power here and here so that the square root gets canceled out. And now we'll be left with x minus 3 is equal to. But now we have to be a little bit cautious and a little bit careful here because we want to simplify the right-hand side of this expression. And in previous problems, we just had a number that we raised to that power. If you had a polynomial like x minus 5 raised to the second power, though, what you should be doing is x minus 5 times x minus 5, because that's the definition of raising something to the second power. So when we simplify this, we're going to use the FOIL method to multiply x times x, which is x squared, x times negative 5, which is negative 5x, negative 5 times x, which is another negative 5x, and then negative 5 times negative 5, which is a positive 25. Combining like terms, we'll have x squared, and then these two middle terms combine to negative 10x plus 25. Okay, so this expression right here, x squared minus 10x plus 25, we're going to now replace this x minus 5 squared with x squared minus 10x plus 25. Okay, so if now you're feeling a little bit apprehensive, a little bit anxious, it's because we no longer have that situation where we ended up with the linear equation. This is now a quadratic equation. And we have to remember how to solve quadratic equations. This is going to require us to get our equation into standard form, which means I need to subtract the x and add the 3 over to the other side of the equation. So I'm going to subtract x here, and I'm going to add 3 here, so that I can get 0 equals x squared minus 11x plus 28. Okay. So we've got a lot more work to do then, because if you recall that, quadratic equations tend to be a little bit more complicated. So now we're solving the quadratic equation. And the quadratic equation here, if it's a trinomial in our quadratic equation, we want to approach this maybe one of two ways. The first way that I always think of is factoring. If I have a trinomial, I might use the AC method that we saw in previous videos to factor that trinomial. At that point, I'll be able to use the zero product property and solve the equation. So let's see if this is factorable. We know A is equal to 1 and B is equal to 28. So A times C is going to be 1 times 28, which is just 28. I'll drop right into my factor T chart. 1 times 28. 2 times 14, I think is going to work. And then I think 3 does not work, but then we'll have a 4 times a 7. And I'm looking to see, do any of these factor pairs give me that negative 11? And sure enough, if I choose 4 and 11, I'm sorry, 4 and 7 rather, then those two factor pairs could potentially multiply to give me the 28 that I want here. And they'll add to give me this middle term, the negative 11, that middle coefficient, okay? But in order to get this middle coefficient, I have to make them both negative, so that negative 4 plus negative 7 gives me negative 11, and negative 4 times negative 7 will multiply to give me that positive 28. So both of those needed to be negative, so that I can now go back to my trinomial here and write this as x squared Now I'm going to use minus 4x minus 7x and then plus 28. Okay. Now that I have uh, four terms, I can factor by grouping. So these guys have an x in common. That'll leave me with x minus 4. These guys, the first term is a 7, I'm sorry, a negative 7, so I'm going to factor out a negative 7 and see if that goes into the 28. Sure enough, it will in this case. So I should have an x minus 4 here, since negative 7 times x gives me the negative 7x back, and negative 7 times negative 4 gives me that positive 28 back. So my factors are going to be x minus 4 and x minus 7. Okay, but we're not done because we need to solve the equation. So we can use the zero product property, that's coming back here, to say, let's go ahead and break this up into two linear equations. X minus 4 equals 0 and x minus 7 equals 0. So if I just add the 4 over to the other side here, I get one solution, which is x equals positive 4. If I add 7 here, I can cancel out that 7, and x is equal to positive 7 here. Okay, so I have two potential solutions, but again, we're going back to the fact that this is a radical expression. So here, we need to check our solutions. So that's going to be step 5. Okay, and in order to do this, we plug both of these solutions back into the original problem. So the original problem, as it was stated, is that the square root of x, which we'll go with 4 first, minus 3, that should equal x minus 5, which is 4 minus 5. So I'm using one solution here, x equals 4, to see, is this a true statement? If I evaluate this in the calculator, I get 1 is equal to 4 minus 5 is negative 1. Okay, let me zoom out so you guys can see. So I plugged 4 back in for both of these x's in the original equation, and I got 1 is equal to negative 1. That is false. Okay, so we have our first extraneous or false solution. What that means is that this potential solution cannot be in our solution set. We need to throw it away. Okay, now we need to check x equals 7, which is our other solution, by plugging it back into the original equation here. So that's going to look like the square root of 7 minus 3 equals 7 minus 5. And this will end up being 2 equals 7 minus 5 is 2. So 2 equals 2. That one is true. Okay. So it turns out that our solution set only contains 7. So if you do not check your solution set, then you could end up putting both of these as your solutions when only one of them is valid. Okay. So make sure you check your solutions, that you practice checking your solutions. Okay, so that we only put in the valid solutions and throw away any of the extraneous solutions that we might run into. Okay. Notice that this problem took pretty much an entire page of work. But I've been telling you guys maybe from the beginning that what we're doing is building a structure that builds upon itself. So we had to have that really strong foundation. In test 1, we saw that we could solve linear equations, that we can use that material to sort of graph different kinds of linear equations. But we were using that really as a stepping stone to get to quadratic equations. Because one of the key ideas in Module 2 was that a quadratic equation can be broken up into two linear equations through factoring in a lot of instances. Okay. Now that we're in Module 3, we're having to put together all of this information that we've seen before to sort of reason our way through. I like to think of it as like peeling back the layers of these different operations, whether they're exponents, whether they're radicals, so that we can cancel some things out and then eventually we'll get to the point of the equation where we just have x is equal to a number or x is equal to a set of numbers. Okay, so you're going to want to pay really close attention to the details for these problems, but really memorize that process. Don't be so obsessed with the numbers because the numbers are going to change from problem to problem. It's the process that remains the same. And as you sort of go through some more practice problems in the homework, you're going to start to develop that sense of muscle memory. You're going to develop a sense of rhythm, and it's going to start to feel a little bit more natural. So if it doesn't feel very natural at the beginning, if you're feeling kind of friction and some tension, making some mistakes, that's okay. Just make sure that you're getting the help that you need by going to Math World and talking to the tutors or by asking me questions in class so that we can address any of those little sticking points that might trip us up when it comes to the homework or worse, the test. Okay. So in the next video, we're going to teach you guys how to solve another set of equations. So look forward to that. I will see you then.